Okay, so today starts day 1 of our Inequalities Unit. So we have 4 days. You can see the homework board. It's just kind of like mainstream inequalities day 1, 2, 3, and 4. What does that mean? That means 4 worksheets, all of which we should complete in class. All right? You might have a problem or two to work outside of class, but other than that, we should be pretty much doing everything inside of class that we need to learn. And today starts day 1 of that. All right, and today we're just looking at basically comparing values, and we actually also have a section that covers equations. We're going to talk about in a minute why equations would be included in your inequalities unit. Like, I thought we were solving inequalities. Why am I solving equations? All right, so, but first things first, let's go ahead and knock out the first section. Number 1, does everybody agree that's equal, right? 4 equals 4. Well, why in the world would they put such a ridiculous question in an Algebra 1 review section? Well, we need to understand the value of numbers, right? That negative numbers are less than positive numbers, and it's just a really quick review of that. All right, so number 2, what sign belonged in the blank on number 2? 7 is greater than negative 2. Okay, so greater than. All right, number 3, negative 5 is less than 4. Number 4, greater than. 4 is greater than negative 3. Number 5, 3 is greater than negative 6. And number 6, 4 is greater than negative 1. I mean, we're pretty much 100% on that, right? Okay, just inequality symbols. Warm up to that. All right, so now number 1 on the bottom section. All right, let's talk for a minute. Why do you think, and you're not necessarily supposed to know the answer to this, why do you think we have equations to kind of start off our inequalities unit? Why do you think they put equations in here? Elizabeth?
To warm you up to...
Sort of, yeah. I mean, it's a warm-up. Because the way I solve equations, and maybe you remember this even from last year, the way I solve equations and inequalities is virtually the same, okay? There's only one rule that's different, and we'll explore that later this week. So when you see these equations, what we're actually doing is we're warming up to actually solving inequalities. And probably one of the best examples I can give you on the difference between the two is inequalities actually has an infinite number of solutions. All right, has anybody ever been to an amusement park? Most of you should raise your hand just from the field trip this year, right? Okay, has anybody ever been on a ride where it says you have to be 42 inches or taller to ride? Anybody ever been on a ride like that? Okay, so give me an example. That's an inequality. All right, give me an example of a height that would be a solution to that, or that would be acceptable. 42 inches. Give me a height that's taller than 42 inches. Okay, 55 inches. What's another height? Give me another height that would be acceptable. Elizabeth?
62.
62 inches. Obviously, would I say 120 inches? Is anybody 120 inches tall? No. Okay, so there's not necessarily infinite solutions here, but would you agree that there's more than one height that would be allowed to go on the ride? All right, you wouldn't walk up to a ride and it says, participants must be 60 inches tall to ride this ride, right? So if you're 59 inches, you can't ride. Or if you're 61 inches, you can't ride. Would it say that? No, absolutely not. That's ridiculous. Okay, so with an equation, there's only one number that makes it true. With an inequality, okay, voting age. How old do you have to be to vote? 18. So if you're 21, can you vote? If you're 65, can you vote? It doesn't say only 25-year-olds can vote. That's it. If you're not 25, you can't vote. No. There's an acceptable range of ages. Does that make sense? That's the difference between inequalities and equations. An equation has one solution. There's one number that's acceptable. Inequalities, there are multiple. So on number 1, again, on this section, we're warming up to solving inequalities. Actually, every single one of these equations I could have replaced with a less than or a greater than sign, and now it becomes an inequality. Okay? So what I'm going to do is I'm going to solve these, but these are not your basic equations. They're going to have variables on both sides of the equation. Does anybody remember what I told you about solving equations with variables on both sides? What do we look at first? What do we do first? What's my step one? Mason? Okay, you're looking for like terms. However, can I just simply add x plus 5x together and say 6x? Okay. What could I do, Lily? What do I need to do? Okay, so because they're on either side of the equation, the equal sign, this equal sign divides my equation. Nothing can be combined that's on either side of this. But what I need to do is I need to get my variables on one side of the equation. So would I subtract x from 5x, or would I subtract 5x from x? What do you think? Okay. Yes. There's not a wrong answer to this, guys. However, if you subtract x from 5x, you're going to have a positive number. You really don't want a negative number attached, okay? Especially when it comes over to inequalities, and we'll talk about that in a minute. Or not in a minute, but we'll talk about it maybe tomorrow or the next day. All right, so I need to subtract x from both sides. What does that do? That cancels out the x's. That's what I want. I want my x's on one side, my numbers on the other. So 16 equals, what's 5x minus x? 4x. And then what do I do to both sides to solve? Divide both sides by 4. Okay, and x equals 4. But I'm not done yet. My instructions say that I must check my solution. So how can I check and know 100% for sure I have the right answer? Sherelle? Plug it back in for what? For x. And there's two x's. So I have to plug in 4 back in for the x on the left and for the x on the right. I have to plug it in both places. Okay? So 16 plus 4. And is it true that that equals 5 times 4? What's 16 plus 4? 20. And what's 5 times 4? 20. So it checks out. All right? Numbers 1, 2, 3, and 4 are all done this way. Okay? So we're going to kind of take a bit of a pause or a timeout. And I want you to start working through these questions. And I'm going to, one-on-one, individually, lay eyes on each one of your papers. Okay? So you need to be working through these problems. And you're doing these just the same way that we did number 1. Okay, then we'll go over numbers 2 and 3 and number 5 together, and you'll do the rest for homework. Okay? All right, so we're going to pause now. On number 2, let's see. Ethan, what did you do first? What was step 1 on number 2?
I added 14 on both sides.
Oh, I would not have done that. You probably could still get to your answer, but he looked at the numbers. Did I teach you to look at the numbers first? No. Okay, you need to look at the variable first. Okay, so you look at 4p and p. Which one would you want to move? Just tell me, Sarah. I would move p because it's less than 4p, right? So how do I get p to cancel to the other side? Tell me. Subtract it. Subtract it to the other side. So if I move my p's to the left, what now is going to happen to my 10s? Move it to the right. It's like a swing move. Okay? Then I'm getting my variables on one side and my numbers on the other side. 4p minus p is what? What's 4p minus p? 3. 3p. Equals, man, so many people are messing this up today, guys. Same sign, add and keep. Negative 24. Negative 24. Divide both sides by 3. P equals negative 8. And then I plug it back in. Don't forget to go back and check. That's a part of your homework grade. All right, so would you agree that wasn't the simplest problem you've ever solved, okay? But it's still inverse operations. It's still opposites. All right, who got number 2 right? Who got number 2 right, or almost right, or you were really close? Okay, awesome. Number 3, okay? If there's one thing you have to be able to leave pre-algebra able to do, it's solve an equation. And I don't mean a simple one-step equation that has a negative with it. I mean an actual involved 2, 3, multiple step equation. All right, let's see here. Josh, what would be step 1 here on number 3? What do I do first? What is it?
Subtract 14.
Very good. Why did he choose 4t? Why not subtract the 6t to the other side? Yeah, very good. I want the number connected to my variable to be positive if at all possible. All right, and that's going to make more sense when we start solving inequalities. There's something that happens when I have a negative connected to it that can make it a little confusing. So I want that number to be positive. All right, so if I subtract 4t, again, it's that swing motion. If I subtract 4t, if I move my t to the right, what's going to happen to my 5? I move my 5 to the left side. I move it to the other side. All right, so subtract 5 from both sides. Now again, guys, your integer rules. Okay, 6 minus 4 is 2. Negative 17 minus 5 is negative 22. Divide both sides by 2. T equals negative 11. Who got that right? Negative 11. Okay, make sure you leave room to check. You need to go back and check. Okay, we're going to do number 5, and we'll be done. Okay? No, we're not doing 4. We'll do number 4 tomorrow when we check it. Now, I'll go by individually. I mean, we still have 15 minutes left in class, and I will check your number 4, but I'm not going to go over it everybody together. That's one that you're going to work on your own. Okay? Number 5, 8 minus 2x. So leave room for number 4 if you have not solved 4 yet. Okay, but we're going to do 5 together. Because something is different about number 5. They added something in here, one more step. Can anybody look at this equation and tell me what's the twist? What makes number 5 different from the other problems that we've solved? Okay. It has 3 variables in the equation. So specifically, remember what I said on the first one, guys. The equal sign splits them. But is there anything on the left side of the equation or the right side of the equation that can be simplified? I must simplify first before I move any terms to either side of the equation. I must simplify. Trey, do you see anything that could be simplified? No, those aren't like terms. Okay, these are not like terms because one's a number, one's a variable. But there is something that could be, what is it? What now? Negative 2x, that's an x. Negative 2x. So negative 2x can be combined with what? Just tell me, guys. 13x. They're both x's. They're both on the same side of the equation. So I can add them together, combine like terms. What's negative 2 plus 13? 11. All right, now I'm right back where I started on numbers 1 through 4. Okay? 8 plus 11x equals x minus 2. Remember what you look for first, and that sets off your chain reaction of what you do after that. Do something first. Everybody should do the same thing first. Okay? And then that'll set off the chain of what you do for the rest of your steps to solve for x. All right? Let's go ahead and finish this one up. Okay, let's see. Sarah, what did you do first? Yeah, subtract x, because x is way less than 11x, right? Now, I had a couple students this morning subtract 11x from x. They just wanted to be difficult, I guess. You can do that. You can, but you're going to have a negative with x. All right, so make sure you get it right. I subtracted x, so if I move my x's, again, the swing motion, if I move my x to the left, what's happening to the 8? It's going to move to the right side. I move my x's to the left side, so that means I need to move my numbers to the right side. You can do that in the same step. And now cancel out what cancels out, the 8's and the x's. So 11x minus x is 10x. Your x's cancel. And what's negative 2, Shantanique, what's negative 2 minus 8? It is negative 10. Same sign, add and keep. Okay, divide both sides by 10, and x equals negative 1. All right, who got negative 1? Who got negative 1? Okay, number 6 works out to be an even number. Number 4 does not. Number 4 will not be an even number. Okay, so that's okay. I think it's a repeating decimal. Just leave it. I'm not worried about you checking number 4 because the repeating decimal, it's not going to check out to be exactly correct. But you do need to check number 6. Okay, so number 4 you will not have to check. All right, and that wraps it up for Inequalities Day 1.